Okay, so before we get started with the coding, let's try and understand how we're actually going to do this project. So one quick little tip, just because things will get a little bit busy. In Ubuntu, if you open up the settings and you choose Appearance and then click Behavior, there's this checkbox here, Enable Workspaces. So I definitely recommend using this. What this does is that it allows you to have multiple, for lack of a better word, workspaces for all your windows. So here you can see we actually have 4 different desktops now, and I can use this just to clear up some space. So for example, if I wanted this browser window to be on another desktop, I can move it over here. So now I have my terminal on one desktop and my browser on another one. So the way you use it is that you say Control Alt and then use one of the arrow keys like up, down, left, or right to move to a different workspace. And then if you want to move a window between workspaces, you say Control Alt Shift and then the arrow keys like this. So this is just a quick tip for how to make things a little bit more efficient. Okay, so let's actually figure out how we're going to do this now. So I'm going to use a separate workspace for the simulation. So let's just go ahead and launch the simulator, just like in the last tutorial. So it's Turtlebot Gazebo, and then you can use tab completion to find the launch file. So now we'll launch the Turtlebot simulation. And here we are with the simulation. And then, just like in the last video, we'll open up teleop as well. So we'll do ROS launch turtlebot teleop keyboard. And so now we can drive the robot around. So here's the robot. And let's try some of those tools that we saw earlier. So one tool was ROS topic list. This will show us all the topics that are being published or subscribed to. So you can see there's a decent amount of topics here. And the one that we're interested in is the ODOM topic. So this prints out basically where the robot is relative to where it starts. So let's do ROS topic ODOM to learn more about it. And you can see the type of this topic is something called nav messages / odometry. So odometry is the name of the type itself. This is the kind of message that goes on this topic, while nav messages is the package, the ROS package, which defines this this type right here, this message type. And you can see that, but this name can be overridden, for example, by a launch file. Alright, so I've finished writing out the boilerplate, so let's walk through what's going on here line by line. You can also, of course, read the tutorial, which provides good examples. So a node handle is basically an object that sort of represents your node and gives you the way to basically subscribe and publish to topics. The next thing, you can see we use the node handle right away to subscribe to the ODOM topic. So the ODOM topic is basically what we were looking at earlier when we were getting the locations of all the landmarks. The next parameter is actually the size of the queue that we want to maintain for incoming messages. So basically, every time we process a message, it takes a certain amount of time. And so if another message comes in while we're still processing the first one, then it'll get added to a queue. So if we process messages very slowly, then we're going to start building up lots of messages in our queue. And if our queue is full, so in this case, if we have 10 messages on the queue, then any new messages after that will simply get dropped. They'll just be ignored. So you can make this really big if you don't want to drop any messages for a while, or you can just make it 1. Like it doesn't really matter in our case. We're going to be doing some pretty lightweight work. And then the final parameter is the name of the callback, which in this case we're going to call ODOM callback. And I put a bunch of question marks here because I wanted to explain how to find what we're dealing with here. So in the tutorial, you can see it uses something called standard messages string, but in our case, we're going to be using something a little bit different. So again, it comes down to the topic that we're looking at, which is the ODOM topic. So as we saw earlier, if you run ROS topic info ODOM, you'll see that the type is actually nav messages odometry. So we kind of want to replace this with we want to replace what they use in the tutorial, which is standard messages, with nav messages, and then put in odometry. And this just means constant pointers, so it's just a special type that they have. And then I think I said before, but basically the first part of this is actually the name of a ROS package, which defines odometry as a message. So we'll actually define our own message inside of the package that we're writing now a bit later. So the way in which you include that is that you include the name of the package, and then you put a slash, and then you just say odometry.h. So that's generally how you sort of include all message types, is that you use this format. And then again, if we look at the message type, so we say ROS message show, and then nav messages odometry, we can see basically how we're going to get to the position, and in particular the XY position that we want. So from the odometry, we need to say, message dot pose dot position dot x. So it's a little bit of a complex data structure here, but basically we need to sort of follow our way down to these leaf nodes, as you were, or if you will. So let's do this. So right now the odometry information is inside this variable called message. So we'll say message, and then we're actually given a pointer. So the first dereference we need to do is with an arrow. And then again, the field at the top level is called pose. And then pose has a field inside of it also called pose, so that's a little bit of a stutter there. We kind of have to write pose.pose, which is a little weird. And then pose has a position, so we need to say pose.position, and then finally we can say .x to get this x variable right here. And basically the message itself is a pointer, but nothing else is a pointer, so that's why we can use dots here instead of arrows. So let's go ahead and repeat for y, and now we can print out the x and y positions. So ROS info is basically a way of logging in ROS, in ROS CPP specifically. You can also use printf or cout, that kind of stuff, but it's not going to really show up if you run this node inside of a launch file, for example, unless you use some certain options. So it's generally a good idea to use ROS info if you just want to print out some information. If you do a Google search for ROS logging, you'll find this thing, ROS CPP overview logging. And there's actually different levels. So there's ROS debug, and there's ROS warn. Let's see. There's more of these. Yeah, warn. There's ROS error, and there's ROS fatal. So these are basically sort of in order of increasing urgency. And what you can do is that you can log all this data, and if you don't want to see some of the less urgent data, you can actually set your log level to cut off, for example, all of the debug info. So if you set your log level at info, then you'll see all of the messages that are of info, urgency, or more urgent, but you'll ignore all of the debug info. But we'll just go ahead and use ROS info for now. And so let's try building this code and see if it works. Hopefully I typed everything out right. So I run cat can build, and it looks like actually it said it succeeded, but we're actually missing a step, which is that we need to actually define what to build. So actually, we didn't build anything at all just now. So one thing that we need to do is that because we're including nav messages, our code now has a dependency on the nav messages package. So in order to do that, we need to add this dependency manually. So we could have done that when we created the package, but we're just going to do it by hand now. So the first thing you need to do is that you need to add a build depend tag and a run depend tag for nav messages in your package.xml. So this will sort of say on a ROS level that your package depends on this other package. But then on an actual build level, you need to edit this cmakelist file as well. So this cmakelist file, I'll do another video that explains it in more detail. So I'm kind of just gonna say what to do in this video and not really explain why, because it's pretty complicated and there's a bit of a learning curve to like really understand what's going on in this file. So first of all, at the top of every cmakelist, there's going to be a find package catkin required components. So this just kind of like brings in some definitions and stuff that you need. So you'll add nav messages to your find package, and you'll also inside here you have a catkin depends. It's usually a good idea to have the same things that you have in your find package in your catkin depends. So try and keep these things in sync with the find package here. And now we need to tell catkin that we actually are building something. So first thing is that we'll say, because we're creating something with a main function, it counts as an executable. So the first argument here, so we're going to add an executable, and the first argument is the name that we want to give to this executable. And then the second argument, and all subsequent arguments, are basically the files that this is implemented in. So here it was location monitor.cpp and not location monitor node.cpp, so we just fix that. Now, whenever you build something, whenever you build something in C++, you need three things. You need to say either add executable or add library. So that's step one. And I'll explain add library later. Step two is add dependencies. So location monitor node isn't just the name of the executable that we're going to create. It's also the name of the target. It's basically just like an abstract name for this executable that's used for the build process. So you need to have the same name here, location monitor node, and you're basically just saying that generating the C++ messages is something that you need to do before you build the actual node. So we're going to define a message later, and we want that message to be built before this gets built. And then the last thing is that you need to link your code, in this case the location monitor node, to the rest of the code that you're using in your dependencies. So this catkin libraries variable will contain sort of represents like all of the libraries that are available that you put in your find package, basically. So each of these defines libraries, and you'll link your code against those libraries. So this is a necessary step. We'll do more examples of cmakeless in the future. It is pretty complex, so I don't expect to explain all of it right now. And just what's the difference between a library and an executable? A library is basically code that doesn't have a main function. So this is like your utility functions, just stuff that doesn't need to run right away. It's like reusable code that you would use later. Whereas an executable is something with a main function. It has a clear start and end. Okay, so now that we've actually done that, now when I run cat can build, it's actually compiling the code. I knew that it didn't compile the code earlier because it ran too quickly. Okay, so now that we've compiled the code, we can actually run it using ROS run. So if you say ROS run and then the name of our package, location monitor, and then location monitor node, we can run it. And you can see that it's printing out all this output here, which is the X and Y position of the robot. That's what we programmed it to do. All right, so again, we're kind of close to the bookshelf, so let me drive the robot towards the center. So we should see X and Y become close to 0. And you can see I've got the X down, but the Y is just a little bit off. Well, anyways, it's pretty close. And as I drive forward, or more towards the cube, the X is increasing in the positive direction, and now X is decreasing. So you can see that we now know where the robot is inside of our node. And this is really just echoing, what we saw in the ODOM topic. So if we ROS topic echo ODOM, you can see that the position X and Y here match up with the position X and Y here. That's just because we subscribe to the ODOM topic and we're now just printing out a subset of the information that we got. Okay, so now that we know where the X and Y position of the robot is, now we want to do something actually useful with it. We want to display where the robot, which landmark is the robot closest to, and what landmark is that. So to do that, we're going to create our own message type called landmark distance. So first of all, let's just go ahead and open up. If you search for ROS message or look at the ROS tutorials, you'll see how to create messages. To start with, you'll want to create a folder inside of your package called MSG, which is just an abbreviation for message. And then inside of your message, you'll write your actual message definition. So in this case, we'll call it landmark distance.message. So a message, you can think of it as just like a list of fields that it contains. And so you can use, each field has a type. So it could be bool, time, integer, string, but it can also be another message type. And it can also be an array of type. So in this case, it's going to be very simple. We're just going to have a string name, which will be the name of the landmark. And then we'll have a float 64 distance, which will be distance to the landmark in meters. And that's all there is to our landmark. Now that you've defined the message, we're only halfway there. We also need to set up catkin to build the message so that it can compile it into C++ code. So to do that, you can refer to the message documentation on the ROS wiki, or you can actually just look at the CMake list itself. So the CMake list has some documentation inside of it on how to create messages. Hopefully this isn't too hard to read. I know it's red on purple, so this one is a little bit more technical. So it has you define a set of messages, or a set of packages, whose message types you use in your messages. So for example, if we had used nav messages odometry inside of our message, then nav messages would be inside of message dep set. But as it is, if we take a look at our message that we created, we only use primitive types. We only use string and float 64. So actually in our case, message dep set is empty and we don't need to worry about it. So the first thing we need to do is add a build depend and a run depend tag in our package.xml. So let me make this a little bit bigger. And I'll go ahead and open up package.xml. So we need to add a build depend for message generation, and we need to add a run depend tag for message runtime. And I'm going through this quickly just because I sort of know it by heart, but do refer to the documentation. It outlines step by step how to do this. And again, if we had depended on some other message, then we would need to add the package that message is defined in here. We would need to add a build depend and a run depend for that. So that's all we need to do actually inside of package.xml. So now in this file, it has a couple of places that we need to edit. It's a little annoying that we can't do this automatically somehow. First thing is that inside of your find package, we need to add message generation to the list. Next thing is that the next step is to add message runtime as well as everything in message depth set to catkin depends. So here we need to add message runtime. And then the next step is to actually add our message files. So we can uncomment this code, and message 1 is going to be landmark distance.message, and that's the only message we have so far. And then the last step is to uncomment this macro here, which says generate messages, and we can actually just comment out this standard messages thing. This is just a template, but we don't have any dependencies. Our messages don't use any packages. So normally, if you did use some package in your message, if you did use some other message type in your message, you would need to list that in here. Okay, so with that, that should be everything that we need to build the message. So let's actually run catkin build. And let's actually take a look inside the devel folder. So if you go into the devel folder, again at the root of your workspace, you'll see that there's this include folder here. So if you look at include, you'll see it has a folder called location monitor. That's our package. And if you look inside there, it's got landmark distance.h. So landmark distance.h is the generated C++ header file that handles all the serialization and deserialization of the message that we just created. So you can see it's got a name field and a distance field, and then a bunch of other kind of ugly looking generated code here. So we typically don't really bother to look at that. It's pretty basic what it does. But anyways, that's how you create a message. Alright, so let's take a look at our code again. So notice that we have a global function here called ODOM callback. So this is the callback that will contain the data from the ODOM topic. Now suppose that we have a list of landmarks. So there's more efficient data structures that you can use, but I'm actually just going to be very happy just having a straight up vector of landmarks. So imagine we have some kind of vector of landmarks, like so. How do we get the landmarks into the callback? So what we ultimately want to do is look at all the landmarks and find out which landmark are we closest to. And so in order to do this, we would have to actually create some kind of global variable like so, and then populate landmarks down here, and then we would have all the landmarks. But I don't really like the global variable approach, and so what I'll do is that I'll actually wrap the landmarks in a class, and then when we subscribe to the ODOM callback, the callback function will actually be one of the methods of that class. So hang tight and I'll show you what that looks like. Okay, so here's the finished class that I have. So what I've done is I've created, well, first of all, I've created just a helper class here called landmark. So this is it's basically like a struct, which tells you the name of the landmark and its position. Next thing is that I created a class called landmark monitor, and it has its own private data, which is a list of landmarks. When you call the constructor for landmark monitor, it's going to initialize a hard-coded list of landmarks, which we recorded earlier. And then finally, the last thing it has is the actual ODOM callback. So this is the same function that we had before, only now it's part of landmark monitor. It's now a method. And we need to change the signature of the subscriber, or sorry, we need to change the subscribe call a little bit. So first, we've created the monitor. Now, when we subscribe, we don't just say ODOM callback, we actually pass in, we need to tell it the class that it's inside of, so we tell it it's inside the landmark monitor class using this syntax right here, which just means it's a function pointer. And then we also give it a pointer to the instance of the class that we have. So this is a landmark, this is the monitor instance right here, so we're passing a pointer to the monitor. And you can actually see this in the ROS, if you search for ROS CPP overview, this is kind of an advanced usage that's not in the tutorial, but not in the ROS tutorials. But there's actually many different ways in which you can subscribe to a topic. So if you scroll down, for example, you can see the way that's in the tutorial is kind of the easiest way. It's just to use a global function. The way that I'm doing right now is to use a class method. So here you can see the exact same syntax. You pass in a function pointer to the instance, and then here's the actual class method itself. And you can also do other things, like you can pass in a functor, which we won't worry about for right now. So this essentially does the same thing. I already built it just to make sure I did it right, but let's build it again. And now let's run it again. And you can see that we're getting pretty much the same output as before. It's just stating where the X and Y of the robot is right now. So, all right, so now let's actually do something more interesting than just printing out the X and Y location, because now we know about all the landmarks. So maybe we can write a method called findClosest. So let's say we're given the robot's current X and Y location, and actually instead of returning void, we'll just return a landmark distance. So we recall that landmark distance is a message that we created. So in order to use this, we need to include it. And what we do is that we just include location monitor / landmark distance.h. So this follows the same format as before. Before there was a package called nav messages odometry.h, and that's how we imported the odometry message. So here we follow the same thing. We have the name of the package, which is called location monitor, and then the name of the message, which is landmark distance. And we're just using landmark distance because it's a convenient format that has the information that we want. So what findClosest will do is that it will return the name of the landmark that the robot is currently closest to, as well as the distance to that landmark. So I'll go ahead and write this out. Feel free to give it a try yourself, also if you want to pause the video. Okay, so here's my implementation of findClosest. So first of all, I have the landmark distance result. So if you recall, landmark distance just has a name and a distance field. I'm setting the distance equal to -1, so here's where I'm going to keep track of the closest distance. And because distance can never be negative, -1 just kind of indicates that it hasn't been set yet. Next, I'm going to iterate over all of the landmarks that we have. Using a standard for loop, I'm going to extract the current landmark for this iteration. Then I compute the x distance and the y distance, called xd and yd. And then I'm going to compute the distance, which is xd times xd plus yd times yd, and then take the square root of that. Oh, you know, I probably forgot to include math.h. I should do that. Normally you actually don't even need to compute the square root if you're just comparing distances and you want to know what's the closest. But in this case I figured we might as well because it's not really a big deal. So okay, and then if the distance is negative, then that means it hasn't been set yet. So the current distance is automatically the closest one. Otherwise, if the current closest distance is positive, but we found a distance that's even smaller, then we'll set the current closest landmark to the current landmark and the distance to the current distance. And so using this, we'll find out what the closest landmark is, and then we return that as a result. So let's see if this builds. Oh no, okay. Right. Sorry about that. So as you can see, we have this thing called landmark distance that we use all the time, which comes from here, location monitor landmark distance. So all the ROS messages are namespaced. So here, notice that when we use the odometry message, we actually put the nav messages namespace in front of it. So for us, every time we want to use landmark distance, we would have to say location monitor landmark distance. So that's a lot to type, so let's just go ahead and just import it as a name. So now that we have the using directive, we can just use landmark distance directly. So let's see if we have any more embarrassing compiler errors. Okay, so looks like we're good now. And now let's actually just see what we can do with it. So now instead of printing out the x and y of the robot's position, let's take a look at what we can. Let's take a look at what the closest distance is. Let's print out what the closest landmark is. So we'll just say landmark distance is equal to find closest x and y. And then we'll say name and distance. And we'll print out the name of the landmark. This is just a thing that you have to do whenever you print out strings inside of a ROS info, is that you can't use a standard string, you need to use a C-style string. So there's this function called C-stir, which creates a C-style string out of standard strings. And then we need to print out the distance, so let's just go ahead and print this out. I'm also taking a bit of a shortcut here. Like normally I would define the class in a header file and then put all the implementation inside of a C++ file. So let's see if this compiles, because I'm kind of worried that might make it not compile. Oh, it works. Okay. Hopefully in the future I'll get a chance to actually do a header file for you guys. So let's try running this. So let's do ROS run. So this is saying that the robot is closest to the bookshelf currently. But let's try driving the robot around a little bit. So let's drive it towards the cube and see what happens. So you can see as we drive it towards the cube, now our location monitor knows that the cube is what the robot is closest to. And now let's drive towards the dumpster. Let's see what happens. All right, so now it says we're closest to the dumpster, and so on. Okay, so now we're pretty close to what we wanted to do, except we didn't just want to print out the information. So printing out the information is different from publishing the information, because when we print out the information to the terminal, it's only us who can see it. Like we have to visually inspect the output. But if you wanted, let's say, another node to be able to read this information, you have to publish it on a topic. So now let's go and actually publish this information instead of printing it. So if you go back to the ROS publisher tutorial, we'll get the basic boilerplate for how to write a publisher. So let's edit our code. And I'll come back to you when I've written the publisher. Okay, so I've finished writing the publisher, so let's talk about the things that I did. So if you look at the tutorial, you'll see a lot of the same boilerplate is there. So a publisher, again, you need to use the ROS node handle in order to create a publisher. So you use this method called advertise, and then you pass in the type of the topic that you're creating, or the type of the topic that you want to publish to. So in this case, we want to publish landmark distances, and we're going to publish to a topic called closest landmark. And so that's what the first argument is, and the second argument is just the queue size. So the queue size is kind of the same concept as before. So now we have this landmark publisher, and I've modified the landmark monitor to take in a publisher as an argument. So if we go up to the landmark monitor, it now has a publisher as one of its class members, and in the constructor, it takes in a landmark publisher as a parameter, and it initializes the landmark publisher. And now, instead of printing out the landmark distance using ROS info, we're just publishing the landmark distance to this topic. So let's see this in action. I already built the code to avoid the embarrassment of last time. And so now let's actually run this. In case you're wondering, I'm pressing Control R and then typing ROS run, which basically will search backwards through your bash history to run a previous command. So as you can see, there's no output, so that's because we removed the print statement that we had earlier, and so there's basically nothing being printed. But we are publishing something, so let's open up a new terminal. Let's take a look at ROS topic list. And if you take a look at ROS topic list, we now have closest landmark being published. So we can take a look at this. Maybe we'll do ROS topic info on closest landmark. And you can see it's of type landmark distance, and it's being published by location monitor. This is the node that we created. While we're at it, let's go ahead and take a look at location monitor. Now that we've written some stuff, so if we do ROS node info location monitor, you can see that we are subscribing to ODOM, and we are publishing to closest landmark. And similarly, if we do ROS topic info on ODOM, you can see that before there were no subscribers to ODOM, but now our node is subscribing to ODOM. So that's pretty cool. So let's see if our code is working. So we'll ROS topic echo closest landmark. And you can see now we have pretty much the same information that we saw earlier. It says we're closest to the dumpster. Let's move towards the cylinder. And as we drive close to the cylinder, it says we're near the cylinder. And as we drive close to the barrier, we define the barrier a little bit farther away. So here's the barrier. So it's working, and we're publishing the closest landmark. Okay, so oops. So let's go back to our code, and we'll do one last thing, which is to print out when we're within half a meter of the landmark. So here we can say if landmark.distance is less than half a meter. So remember, the zones are 1 meter in size. So if we want to create a 1 meter diameter circle, then we need to be within half a meter. So we'll say if the distance is less than that, you could also say less than equal, why not? Then we'll say ROS info, I'm near the, and then we'll go ahead and just print out landmark.name.cster. Remember the cster when you're printing out these things. Okay, so now we should see when we run our node, it says I am near the barrier, which is good because it was near the barrier. And now let's drive the robot around, maybe back to the shelf. Let's see. So now you notice that the robot has stopped printing stuff out altogether. So it's kind of left the zone of the barrier, and it's not printing anything. As we get closer to the bookshelf, within a half meter, it says now I'm near the bookshelf. And similarly with the cube, so now it looks like it's saying it's near the cube. So it's a little hard to tell when it's printing, just because I'm sort of cutting off the output a little bit. But let's try driving the robot away. And now it's not near anything, so it won't print anything. So we can clean up the output a little bit more, like maybe you don't want it to print out so many times, but we won't worry about that for this tutorial. So yeah, I hope that this tutorial helped you understand a bit about publishers and subscribers. We did a lot in this tutorial because there's kind of a very steep hump to get over once you know ROS, and so hopefully we'll be able to learn more concepts in smaller bites in the future. But thanks very much, and look out for the next tutorial.